Welcome to V-Teach. In this video, I am going to discuss about the sharpening filters. Whereas smoothing filters or averaging filters are used to blur the image, and the main application of blurring filters is to reduce the noise effects like impulse or salt and pepper noise. But this is in contrast to smoothing. Sharpening filters are useful to highlight a particular detail. So sharpening used to, as the name indicates, the sharpening, it is used to highlight the some fine details. So in the contained in the image. Since the smoothing is obtained by using the averaging operation, in a continuous sense, averaging is nothing but integration. So as opposite to the integration, here the sharpening is achieved by the differentiation. Differentiation of the gray level values, which is in one dimensional case, it is defined as the sharpening is defined as the df by dx is equals to f of x plus 1 minus f of x. That means in one dimensional case, that means along x axis, suppose if this is a pixel called f of x and this is x plus 1, which is lies on the same row y. So difference between the gray level values of these two, f of x plus 1 minus f of x. So this is called the derivative, one dimensional derivative in x direction. Similarly for y direction, we will take y, f of y plus 1 minus f of y is the first order derivative, which is called the first order derivative in x direction. So this has to satisfy, first order derivative has to satisfy some properties such as it must be 0 in the areas of constant gray level values. That means if you find the difference like this, f of x plus 1 minus f of x, if gray level values are constant, that means both are having 5, then it gives a 0. That means there is no difference. So since we are finding out the differentiation, if there is a constant gray level values, that means suppose if there is a complete white background is there, then there is no difference. All the pixels are having the maximum values like 255, all are bright pixels, then we can assume the intensity values of the background pixels are 255. In such a case, if you apply the differentiation, we won't get any difference. So that means derivative should be, that is dou f by dou x should be 0 in a constant gray level values, and it must be non-zero at the onset of a gray level step or ramp. Gray level step or ramp means we can define like this, a step or ramp. So whenever this kind of profiles will obtain in the image when there is a sudden change in the gray level value. That means suppose along x-axis, if you consider the first pixel value is 5, second pixel is 5, and third is a 50, fourth is also 50, and again 5 is there. So this kind of profile, that means gray level value profile, is represented as a step. That means here there is a sudden rise in the intensity values at the third pixel, and fourth pixel is also having the same intensity level, and again it came back to its normal value, that is the 5. So that means this is called a sudden rise at the third pixel and sudden fall at the fifth pixel. So this is represents a onset at the step. Onset means this value. This is the onset at the step. Similarly, ramp kind of thing. That means there is a gradual increment of the gray level values to a highest level. That means suppose up to this, the values are constant. Suppose 10, 10, 10, and there is a sudden rise. That means it is the step value increases to 100 and thereafter gradually increases, linearly increases. That means at the onset, that means at the starting point and here, these two are called the onsets of the ramp. At the onsets, that means since there is a sudden change from previous pixels to this onset value, so at these points the derivative should be, that means the difference f of x minus 1, f of x plus 1 minus f of x should be non-zero. That means this non-zero value obtained at the onsets. But see, during this value, that means at the step, both are 50 and 50. So again here if you find the difference, it becomes a 0. That means duration of the step, it won't get the non-zero value. Only onset of the gray level step or ramp, the differentiation value should be non-zero and must be non-zero along the ramps. Since the ramp, if you see this one, there is a gradual increment is there. That means the gray level values also changes. There is a change in the gray level value. So it should be non-zero along the ramps. That means only the first order derivative yields a 0 value when there is a constant gray level value, gray level values are there. Similarly, the second order derivative is defined as dou square f by dou x square. So which is f of x plus 1 plus f of x minus 1 minus 2 f of x. So similarly, as we have discussed in the first order derivative, we see f of x plus 1, this is f of x. Suppose this is a coordinate along the x direction. X minus 1 is this one and x plus 1 is the pixel towards right side. X minus 1 indicates the pixel lies left side of the x. Second order derivative defines x plus 1 plus x minus 1. The intensity values at this position and this position minus 2 into f of x. So this particular value yields the second order derivative in x direction. Similarly for y direction we can define dou square f by dou x square as f of y plus 1 plus f of y minus 1 minus 2 f of y. This is the second order derivative. So there is a slight change between first order and second order derivative properties. Similar to the first order derivative, second order derivative is also 0 at the constant gray level values. That means again if you assume here all are 5. 5 plus 5 is a 10 minus 2 into 5. 10. If you calculate the second order derivative in x direction, it will be 0 and it should be non-zero at the onset and at the end of the gray level step or ramp. So this is called the onset and this is the end. Here also onset and end of the gray level values of the step or ramp, it should be non-zero. Must be 0 along the ramps of constant slope. That means if a constant slope ramp is taken, so this is the main difference between the first order derivative and the second order. First order derivative is a non-zero along the ramps. That means irrespective of whether it is a linear ramp or non-linear ramp. That means with constant slope or changing slope, the first order derivative should be non-zero along the ramps. But if the ramp is having the constant slope, then it should be 0. The second order derivative yields a 0 value. That means if it is constantly changing, if you observe the equation f of x plus 1 plus x minus 1 minus 2 f of x, if it is constantly changing, there is a, suppose each pixel is differentiated by 1. That means it is 5, 6 and this is 7 like this. Some equal amounts. The difference along the ramp is changing by a fixed value. Then if you calculate this expression, the second order derivative gives a 0 value. So the third point is the major difference between the second order and the first order derivative. The application of the derivative for highlighting particular portions of an image, that means sharpening, depends upon the selection of these two filters depends on the application, where the major difference lies in the ramps, along the ramps. First order derivative is irrespective of the ramp, whether it is a constant slope ramp or a differentiating slope ramp, it must be non-zero differentiation because it is taking the difference between the successive pixel values. That means suppose it is changing constantly, this is 5, this is 6 and this is 7, constantly changing. 6 minus 5 gives a 1, 7 minus 6 gives some non-zero value, it gives some non-zero because it is the difference between the immediate pixel values. But second order differentiation is not difference between the immediate values, it involves the 3 pixels in a row. So in such a case, if the slope is constant, so it gives it must be, second order derivative must be 0. The second order derivative, using the second order derivative, we can define an operator called a Laplacian operator, which is denoted as del square f, which is dou square f by dou x square plus dou square f by dou y square. As already we have defined what is dou square f by dou x square. That means second order derivative along x direction and second order derivative along the y direction. So by combining these two, that means this gives us in 2-dimensional, that means for an image. So we can define this equation in the form of a coefficient or filter, as already we have defined in smoothing filters, that is mask W as like this. So this is one filter and this is another filter. So these two are called the Laplacian or gradient filters. So where this equation, if you observe this equation, if you convert this in the form of a filter, the center pixel, that means at x comma y, assume the coordinates of x comma y are the center pixel values, its coefficient is -4 and f of x comma y minus 1. Y minus 1 means this one, x on the same row, y minus 1 is this one, sorry, this one, 1, and all these coefficients x plus 1 comma y, x minus 1 comma y, x comma y plus 1 are the 4 neighbors of this one, and the remaining coefficient, that means diagonal neighbors, are 0. So this is the filter, that means the Laplacian is converted into a filter mask whose coefficients are like this, and another mask which is the center coefficient is -8 and the remaining values, all the 8 neighbors are equals to 1. If you observe these two coefficients, there are another type. Center one is negation of this one, center one is positive and the remaining ones are negatives. Similar to this one, center one is positive, remaining ones are negative. If you observe all the 4 coefficients, these sharpening filters, the sum of all the coefficients must be equals to 0. If you observe the sum of all, that means as we observed in equal, that means uniform gray level region is there. So it should be 0. Its value should be derivative value, whether it is a first order derivative or second order derivative, it results a 0 value. That means if you apply any of this mask in a constant gray level region, that means if you observe a 3 by 3 portion of an image where all the gray level values are equals to 5s, suppose let us say randomly all the gray level values are 5s. If you apply any of this mask to this portion of the image, it results a 0 value, because sum of all the coefficients is equals to 0 in any of these filters. So it gives a 0, it results a 0 value, which satisfies the first property of first order and second order derivatives. That means if the filter, that is first order or second order derivative, is applied in a constant gray level region, its value should be 0. That means constant gray level region means there is no portions which are highlighted. That means all are having equal gray level values. That means if you assume, so 0 to 255 is the actual range of the gray level values of an image. So 5 means almost these pixels appears in black color. That means all this portion, a 3 by 3 portion, appears like in a black shade. That means there is no region to be highlighted in this particular portion. So if you apply the derivative, whether it is a first order or second order derivative, it results a 0 value. And similarly to the Laplacian, there are other filters also there which are used for the sharpening, which is based on the Laplacian, and another variable that is defined as a gradient, which is dou f by dou x, dou f by dou y, which is nothing but the first order derivative. It is another form of the Laplacian. So these are other filters used to highlight the particular values in a specified direction. See, if you observe this one, if any discontinuities are there in the horizontal or vertical lines, these filters are used to highlight those portions. If you observe the coefficients, again sum of the coefficients are equals to 0 in these filters also. So these filters are defined by gradient operations. That means difference, nothing but the forward differences, Z9 minus Z5, Z8 minus Z6. So these are the filters where Z1 to Z9 are the filter coefficients. These are some of the filters defined for the sharpening of the image. So these are called the two masks defined in B and C. That means these two, B and C, are called Robert cross gradient operators. Means each gradient is having one particular name, which is Robert cross gradient operators, where the third one is defined in the form of an equation. If you observe the third one, that is D. See, minus 1, minus 2 and minus 1 are for the first pixels. That means Z1, Z2 and Z3. Z7, Z8 and Z9 are this last row. So that is written in the form of equation Z7 plus 2Z8 plus Z9 minus Z1 plus 2Z2 plus Z3. So these are defined in the form of a gradient. The gradient operation applied on like this, dou f by dou x and dou f by dou y, differences in x direction and y direction. These are represented in the form of filters. So these are called Sobel and Prewitt operators. These two, D and E. These two filters are also known as the Sobel operator and Prewitt operator. These are some filtering techniques based on the first order and second order derivatives. In addition to these filters, there are two techniques which are called Unsharp Masking and High Boost filtering. So these are used in the printing technology. These two techniques are useful, Unsharp Masking and High Boost filtering. So these are used to highlight a particular portion. There is some procedure. So for Unsharp Masking, if you see the Unsharp Masking, these are the steps to get the Unsharp Masking. First, blur the original image by applying any of the blurring filter, as already we have discussed the averaging filters. So by applying a weighted average or normal average filter, first blur the original image. So subtract the blurred image from the original. That means if you take f of x comma y is the original image. So blur the image and subtract the blurred portion. Suppose f dash is the blurred version. So this is called, the difference is called a mask. That means which is the difference between original image and blurred version of it. This is called a mask. This mask is added to the original image. That means f of x. Here this is defined. G mask is nothing but the difference between original image and its blurred version. So it is added to the original image. The mask is nothing but the difference between original and the blurred portion, which is added to the original image. The resultant one is called the image is obtained from the Unsharp Masking. If k is equals to, k is a weighted coefficient, if k equals to 1, that is called Unsharp Masking. If k value is selected as greater than 1, that means k value represents the weightage given to this mask. That means the difference between original and its blurred version. That means how much amount, that means the detail to be highlighted in the original image. That means if you subtract the blurred version from the original image, so what are the sharp features present in the image will be highlighted. That means suppose in printing technology, particularly letters, suppose if you assume the letters are on the in black color, which are published on the white background. So particularly these are highlighted because this particular gray level value is completely quite different from its background. So these obviously these characters will be highlighted. So like this, if you subtract the blurred portion from the original image, sharp features will be highlighted, and that amount of highlight is given by the, we can decide it by the coefficient k. If k value is 1, that is called unsharp masking. K is greater than 1, it is a high boost filtering, and k equals to 1, so which reduces the effect of this mask. So these unsharp masking and high boost filtering, these are also comes under the category of sharpening cases, along with the operators which we have discussed, that is first order and second order derivatives. These are particularly in publishing, that means printing industry, these two techniques finds its application. So this is about the sharpening filters, and we have discussed the complete smoothing and sharpening filters and intensity transformations. So these are all spatial domain techniques. That means spatial domain is nothing but the image plane itself. So that means directly on the pixels present in the image, these operations are to be performed. So this is about the spatial filtering. Thank you.